Welcome to Unit 12, Lecture 5, the last lecture in our climate and climate change unit. Lecture 4, we kind of talked about what climate change was, what was driving it. We talked about the greenhouse effect, greenhouse gases, and issues that have arisen that we've seen arise because of the amount of greenhouse gases we seem to be pumping into the air that normally we wouldn't see getting pumped into the air if we didn't burn the fuels we burn or manufactured the way we do. In this lecture, we're going to look at some of the effects of climate change. So, what is this showing us? Or what could be to come? So we're going to start off by talking about what the consequences of a warmer Earth would be. Now, one of the things we have to keep in mind, we've seen a rising trend in average global temperature. So that's a lot to kind of take in, and it's a big contention. So I'm going to just kind of lay it out, what we mean by average global temperature. We look at the temperature of the entire globe. Alright. Add them together, divide by the number of stations to get an average for a year. And then we do it for the next year, the next year, next year. And what we see is, yes, some years are higher than others, some years are lower than others. But overall, if we put them on a graph, we see the slope increasing. It's increasing somewhat. So that is the rise in global temperature. Alright, that we're talking about. Now, some other evidence of this, alright, this warmer Earth than it was. We look here in North America, we see some birds nesting about 2 weeks before they did 50 years ago. Alright? And if we look over across the Atlantic Ocean to Europe and Britain, we see plants flowering 55 days earlier, or a month or so, maybe even a month and a half more earlier than they did 40, 50 years ago. So what we are seeing is that birds nesting, which is a sign of springtime as it starts to get warmer out, plants flowering, which also has temperature driving indicators, not just the amount of sunlight, but also what the temperature is. It's usually a combination of the two. We see those happening sooner in the year, which means that it's getting warmer sooner than it used to. Or it's just overall warmer, and so we hit those temperatures a little sooner. So we see these effects: birds nesting sooner, flowers blooming sooner. And this can lead, if we extrapolate it out, if we look out, estimate it out into the future, we can see a lot of potentially serious problems. Now, we cannot predict the future. We can use what we know of what's happening now, what we know of what has happened in the past, to project what we think will happen in the future. All right, we do that with a lot of different things. All right. The problem is some scientists speak with absolute ideas of this is exactly how it's going to be, and we don't really know because we can't predict the future, but we can give our best estimations, take our best shots at what we're seeing. So we can see the potential for large changes in weather patterns and sea levels. All right, now the big thing is that this warmer Earth will not be the same everywhere, and different countries will handle the changes differently. All right, we're still considered a wealthy country. Yes, we have enormous amounts of debt to various other countries, but we're still considered a wealthy country overall. So we probably have a better chance to adapt than a country that's considered really poor. All right. Plus, it all depends on the issues that the country faces for how much it's going to cost. All right. So we're just kind of speculating, looking ahead at possible potential outcomes based on what we know warmer temperatures will do. The timeline varies, and if you take 100 scientists and just random sample size and ask them based on their fields of research, their studies and everything, they'll probably give you many different answers of how long different parts of these effects of climate change will take place. Right? It's not a consensus in the scientific community. But we are learning, and with every study we do learn something. So let's talk about rising sea levels. All right, we've been measuring sea level over the past 100 years or so. All right, and what we've noticed is that sea levels are rising. One of the reasons they're rising is we're taking water out of glaciers and putting it back into the rest of the water cycle. All right, which means they will end up in the oceans. So we are pretty much adding water that's stuck frozen on land in glaciers and adding that to ocean water. And that's causing the sea levels to rise. And as long as those glaciers keep melting, we're going to keep adding more and more water. All right, now if all the glaciers were floating in the water, well, then we wouldn't see a rise. It's like an ice cube floating in a drink. It would just melt and stay the same level. But these glaciers are not all floating in the water. Some of them, like the ones over Antarctica, are over a huge piece of land. All right, others are up in really high up in the mountaintops of like the Alps and the Himalayas. And so that water, as those big chunks of ice melt, that water has to go somewhere and eventually finds its way into the ocean. The other thing that we see is water, and we're going to get into water in the next couple of units. Water has these really weird little properties, all right? Yes, it expands when it freezes, which is weird. It makes water very, very weird among liquids, that it expands when it freezes. But it also expands as it warms, which is kind of weird. So when you have water at around 2 to 4 degrees Celsius, it's at its densest and it is most compact. And then as it either warms or freezes either direction from that 2 to 4 degrees Celsius range, either way, if it gets colder, it's eventually going to freeze and expand. If it gets warmer, it does what most things do as they get warmer, it expands. So as water warms, it expands. And ice over land is melting and adding into the water. So what we could see, and I emphasize could, is we could see flooding coastal areas, all right, low-lying areas. Now we've already, at least in my class, I've talked a little bit about New Orleans and the big problem with Katrina when the levees that pump water out of New Orleans busted. Well, we built New Orleans below sea level. At the time it was there. Like when we built it in the 1800s, we built it below sea level. Not the smartest place to build a city necessarily, but really easy to build a city there and know the sea's right there for shipping regions. And New Orleans was a big shipping port in the southern area there, right into the Caribbean. So it was really good for that, but really bad for when water comes into the city because it's below sea level. So one of the things we could see is we could see the erosion of beaches. We could see bays, estuaries of water that's normally fresh water get saltier. And we could see this affect freshwater aquifers, and this would change around aquatic life because it could decrease freshwater resources. All right? And so because of all that, we could see large problems in freshwater resources. Second thing is global weather patterns. And now we need Earth to warm significantly, more so really than it already has. But ocean water is one of the darkest substances on the Earth. It absorbs more energy as heat. And so there's more energy in the water being absorbed as heat. So then when that water evaporates, there's more latent heat in the atmosphere as it condenses, and we could see hurricanes and typhoons become more intense. Now, this is a weird little thing with just the severity of these storms. However, we also could see, and we know this has happened in the past, if something happens that changes ocean current patterns, like the Gulf Stream runs up from the Caribbean up along the East Coast and then across the northern Atlantic over to Europe. It's why countries on the western edge of Europe experience milder weather, at least temperature fluctuations, than we do, even though we're at the same latitude as them. They're getting warm water, essentially blowing up, warm water and air blowing up from the Caribbean. So this could change if something happened to kind of divert or shut down the Gulf Stream. Europe could get a heck of a lot colder. And that warm water in the Caribbean could be going somewhere else, making a different area warmer. So that could drastically affect weather patterns. All right, and it could cause severe flooding, because some regions might get lots more rain and other regions might get a lot less, and we could see droughts and fires in other regions. We kind of see this on our west coast right now. They're having severe water shortages and droughts, and every summer we hear about the forest fires raging through California. And while we did talk about the fires being good for some of the ecosystems, them raging out of control is not good. And the water issues they're facing, they seem to be getting worse every year. As we would see temperature go up, we could see more heat-related deaths. All right, we could see more problems from allergies. Now, like you were talking about, all these doomsday things, and here I am bringing up, those people with those allergies might be sneezing a few months earlier and suffer from allergies more of the year, and wow, what a consequence of global warming. It's just another thing to kind of look at. Again, this is not something we know the full extent of. We're just taking what we know. If we know that plants are flowering earlier, that means their pollen will be in the air earlier, and they could affect people more often. All right. Certain insects, like mosquitoes, that like to reproduce in warm, moist places. Think of our humid summer times and the mosquitoes that come. They would have more time of year to be able to reproduce and establish themselves that they're normally not in. I mean, we get mosquito season for a couple of months here. Maybe if the world gets warm enough and our climate gets a little bit warmer overall, especially spring, summer, fall months, the mosquitoes are able to kind of take hold a couple of weeks sooner. Now, we know that they are vectors, that they carry diseases like malaria, dengue fever. So now we have a bigger chance of being exposed to those diseases just because they're the insects that transfer them are around a little more. Agriculture could be impacted. It depends on water levels. I mean, if the weather patterns are changing even slightly, and an area that used to get a lot of water is getting less, that could cause droughts, and that area could not be as productive for planting. Other areas could therefore become more productive for planting because rain will fall somewhere else. It's just, can we then take that land where the rain is falling and get it going to be as successful of a crop producer of land that might be going under drought? High temperatures can also change the amount of production a plant has, so we could see a decrease in crop yields. We would need more water for irrigation, and in a lot of the scenarios, fresh water becomes a major commodity. There's not a whole lot of it. Remember, 97% of the water on Earth is unusable. It's either tied up in glaciers or in the oceans as salt water. And a good chunk of that is right here in the Great Lakes. And then you can add the Finger Lakes in, but they don't really add as much as the Great Lakes do. So we are in an area that could become a very, very important area for the future. And that's probably not necessarily a good thing. Right now, oil is a big commodity. Think of the area, the planet that seems to be rich in a lot of oil. All right, that's the Middle East. Lots of civil unrest and fighting going on there, and you can find arguments for most of that happening because of the oil and people wanting the oil. So could that happen in our area for the fresh water? If it gets bad enough, maybe. Again, it's speculation based on data we have seen. We don't know for sure. Plants can be affected. Plants could end up with a larger or smaller range of plant species. It could change the plant communities. We know the plants are very important for the biome, and they're usually the lowest trophic level of food webs, and so it could cause a change in the major biomes, terrestrial biomes around the world, and that would impact the numbers of different species. And so we could see more species go extinct and lose biodiversity there, and then we could see other species do well in other places, and might increase diversity a little bit. It's hard to tell. But we could see like a shift in ecosystems, either due to fires or due to just different trees and different plants being in an area that are not usually there. And then if they don't have any natural predators, they could take over for the plants that might already be there. Of course, if something affects plants, it will also affect animals, as if you follow the food webs, they all start usually with a plant. So we might see a change in the migratory patterns of northern birds. They're not flying as far south, which just means they might be impacting little local ecosystems here and there. But the one that I really look at and think could cause a problem is if there's more ocean, either left uncovered from glaciers or just covering parts of the land, that's more water absorbing the sun's energy. Now, it takes a lot of energy to heat water. Right? If you've ever just stood there and waited for your couple of quarts of water to come to a boil before you throw your pasta in for your mac and cheese or whatever you're making, you know that it just seems like it takes forever. So water can retain a lot of heat, and so that's kind of a good thing. It takes a lot of energy for water to get warmer. But if it does get warmer, it could change the amount of zooplankton, little tiny microscopic shrimp-like animals. This is the best way to put it. But these little tiny animals that are a lot of times the zooplankton might eat the phytoplankton, which are the algae, the plankton that do photosynthesis. Then these eat those. But they are at the low levels, the low trophic levels in oceanic environments. And so if it causes a reduction in the zooplankton because they can't handle the different temperature, a lot of times unicellular organisms might not always be the best at adapting to changes in temperature and everything. So because of that, we gotta watch out for it. We could see a large disruption in oceanic food webs. All right. In the tropics near the equator, that water should get even warmer than it already is, and that could cause problem for algae, the phytoplankton, which could end up destroying coral reefs. We see a lot of coral reefs not handling pollution of the water too well. Do they need another stress? Also, as there's more carbon dioxide in the air, it'll seek an equilibrium with some of it, more, maybe a little more dissolving to the ocean. So water could become more acidic, although as the water warms, it will not be able to hold as much carbon dioxide, because as a liquid gets warmer, it can hold less gas in it. It's this weird solutions thing. You'll talk about it in chem a little bit. So that could cause a problem as well. Just other problems that could, or other issues that could potentially become problems. And pretty much we're just taking what we know. I can't really stress this enough. We're taking what we know. We're looking at the data, and we're taking our best guesses on how this could continue on in the future. We haven't seen anything like it before. We haven't been through it before, so we don't know with 100% surety what will happen. All right, recently we've taken a look at things as far back as, well, not as far back as 2007, but we looked at 2007. There was an international panel on climate change. They came up with what is known as their fourth assessment report. What they noticed is that between 2001 and 2007, there was a 0.74 degrees Celsius increase in the average global surface temperature. All right, so we saw this increase at global. We saw it be global. We covered almost the entire world, and we saw it a little higher at the northern latitudes than the southern latitudes. And we also saw global sea levels rising. So, and thirdly, concentration of greenhouse gases also increase. So they kind of all go together, right? The concentration, more greenhouse gases should trap more heat, all right? The more heat that is trapped, the warmer it should be. And the warmer it should be, the more ice should melt. So they all kind of fit together real nice. And really it's just, do you believe the scientists measured the data correctly as to whether or not you believe this is happening? Now, the other key is that, are humans the only cause? All right? We do know the Earth has experienced periods of dramatic warming and cooling in the past, going into ice ages, coming out of ice ages, glacial and interglacial periods, and that all needs to be taken into account as well. The one thing we pretty much know for certain is that people have not been responsible for increasing greenhouse gases at the level we are now. But, speaking geologic timescale, geologically speaking, what we're doing is taking up such a small, teeny, tiny piece of the geologic timescale. I'm pretty convinced that no matter what, Earth itself will end up being fine. We'll probably more likely to kill ourselves all off first, kill all people off, and then Earth will find a new equilibrium and new balance. But I don't want just Earth to be fine. I'd like to see Earth with a thriving human civilization to also be fine. And so I think that is really where we're looking to aim at these limiting certain human activities and everything, is how can we keep the planet in a state that it's not getting too difficult or hard for us and other organisms to maintain the current level of life that they have. We need to, in order to slow a global problem like this, we need a whole global community. The problem with that is that the whole globe is at different stages of development. We are a very, very, very well-developed country. Some other countries are not so well-developed, and others are just beginning to develop or aren't even there yet. So part of the problem is we need to deal with the economic, political, and social factors by all these different countries. All right, and as you've watched Cool It in class, one of the reasons I like that documentary for the class so much is because it brings up these issues of India and China, who are right now going through the developing process about 100 years after we have. And we see a lot of the same things happening. They're burning more coal, burning more fossil fuels, which is putting more carbon dioxide and stuff into the air. And we're trying to be like, well, no, you can't do this. We did it, and look what happened. But they're not going to listen, because that is how they can get ahead, and they want better lives for their children. And there was that part in Cool It where he went to the school in Africa, and all the kids are kind of talking about the biggest issues, their biggest fears are healthcare and food and housing. Which is a lot more important if you don't have that stuff. It's a lot more important to be healthy with shelter and food than it is to regulate the climate, especially if you don't have good health, food, or shelter. If you're missing health, food, and shelter, I don't think much else should really matter to you. And so it's a tough little balancing act. We can do what we can and try to help the countries along, but we don't want to necessarily impact their quality of life. They have every right to get the best quality of life that they can, just like I think we have. So, I mean, I'm probably getting too opinionated here. I really don't want to force opinions on you guys, but I'm just trying to bring that up, that we have to keep in mind that everybody does not live where and how we do. All right, so we've noticed conflict between developed and developing countries over the future of carbon dioxide emissions. Developing countries are going to release more carbon dioxide, have it regulated less, because it's going to be economically, financially more viable for them to do so. So that's a big thing, and we're expecting. Here's that projected word. We're expecting them to be making up half the emissions by 2035. I'm not sure that's necessarily a bad thing. It's probably stemming from the developed world reducing theirs and the undeveloped world using more. And so hopefully, if the developed world starts producing less carbon dioxide, that will offset the developing world using more. And at least maybe we can try to get the levels under control, and eventually, once more of the world is developed, we can take bigger and broader steps into reducing the overall emissions. All right, the Kyoto Protocol was a treaty in 1990. The U.S. Didn't ever ratify or sign the treaty. Same with Canada, Australia, a lot of countries. Pretty much it was Europe. Europe was like, yeah, we'll do this. And they've spent billions of dollars on it since then. But you're not going to be able to stop greenhouse gas emissions if you don't have the countries producing the most of them, the most greenhouse gases on board. So there are still governments and organizations trying to find ways to reduce the greenhouse gas emissions. To kind of, let's see what this does to these climate change effects we are seeing. All right, let's see if we can lower these. Is it going to do what we expect it to do? Or is there more going on and we can't see it yet because we're kind of blinded by it's got to be this? So there's all sorts of questions kind of answer. The Kyoto Protocol came up in 1990. They talked about it in Cool It and the cost of it. So just know it was a global push to try to reduce carbon dioxide and greenhouse gases, but a lot of countries didn't buy into it, mainly because of the cost of it. And this is the last slide, just showing this. This is looking 1995, where most of the CO2 emissions were coming from. Mostly the U.S., by far the largest producer of CO2. and then, well, actually not the largest. Eastern Europe, and the FSU is former Soviet Union. I missed that one. But we're one country, Eastern Europe, former Soviet Union, a lot more, a lot bigger area. We're expecting that as some of these other countries listed as developing countries to continue to develop, we'll see more of them adding in. I would have liked to see a little chart that had India, pull India out of other Asia. So it's not in there, but I would think most of other Asia might be being made up for by India. Also probably Southeast Asia a little bit. But you can see China's expected to rise, and I think they're rising faster than this will show. We are bringing our percentage down, but this is just a percentage of what's being released at that time. It doesn't really give you any hard data of exactly how many tons of CO2 by each country. It's more of just a percentage thing. So it's definitely being spread out more percentage-wise, but the other thing that's happening is it's more overall. So the U.S. amount of CO2 could stay the same or even increase in terms of raw tonnage of carbon dioxide, but the percentage goes down. So this doesn't mean we're necessarily doing a good job. It just means other countries are developing and using more. That is it for this lecture and this unit worth of lectures. If you have any questions, please bring them in. And pretty soon we'll be starting our last few units on the year. We're going to talk about water quite a bit over these next few units and how awesome of a substance that is. Thank you and have a good night.